2-5, product rule. All right, what the product rule does is the rule intended to show you how to take the derivative of two or more functions multiplied together. So product rule. It's the rule intended to show you how to take the derivative of two or more functions multiplied together. For instance, let's look at an example. So there we have x squared times x squared. All right. Normally, the derivative of x squared is 2x, which is correct. So would this be 2x times 2x, which equals 4x squared? No, this is wrong. That is not how you do that. How you do product rule, and I purposely picked a simple one like this, okay? Product rule, because technically this is an x to the fourth, which will give you 4x cubed. All right, when you do the product rule. So the way this goes, because you just can't simply do the derivative of this and multiply it by the derivative of that. All right, it's not that simple, unfortunately. It'd be nice if it was, but it's not. So say if h of x, I know y'all probably hate when I do this, equals f of x times g of x. All right, then that's kind of sloppy. Let me fix that up. F of x times g of x. Then h prime, remember, prime is your derivative, h prime equals f of x times g prime of x plus g of x times f prime of x. All right, that gives you your product rule. H of x is the first one times the derivative of the second plus the second times the derivative of the first. It's a little kind of stupid rhyme if you like things like this. You can think of it as 1d2, 2d1, okay, 1d2, 2d1, add them up, and then you're done. Right, kind of a dumb thing, but so this is 1d2, 2d1, all right, add them together, and then you're done. All right, that's your product rule. That's simple. All right, so let's go back to our original example that we had. X squared times x squared. All right, this is our first function, this is our second function. So if you remember the rhyme, it's 1d2. So 1 is x squared times the derivative of the second, which is 2x, plus 2d1. So your second function, x squared plus 2x, times 2x. So this is 2x cubed plus 2x cubed, which is 4x cubed, which is the correct derivative for, because remember, this multiplied together gives you x to the fourth. So as you can see, this gives us the correct derivative. So you take the first one times the derivative of the second plus the second one times the derivative of the first. All right, let's look at another example. We want the derivative of x squared times sine x dx. All right, so what is this? Well, x squared is your first function, sine x is your second function. So if you remember, 1 d2 plus 2 d1, so x squared, what's the derivative of sine? Hopefully you said cosine, because I can't hear you if you did or not, times 2, which is sine x, derivative of the first one, which is 2x. All right, so our derivative is x squared cosine x plus 2x sine x. All right, that is our derivative of x squared times sine x. All right. Hopefully this doesn't seem too complicated. And of course, what seems easy, I usually like to complicate. And so guess what I'm doing? Let's look at another example. Let's take the derivative of x squared times sine x cosine x. I always like to mess things up a bit, don't I? Well, now we have three functions up here. We have x squared, sine x, and cosine x. Well, now that kind of messes up our rhyme, don't it? Well, in a way it does, but in a way it doesn't. Remember how it was the first one times the last one? Derivative of the last one? Well, now it's 1, 2, d3, and then you're going to have 1, d2, 3. Then you're going to have d1, 2, 3. All right? So if you look, your derivatives kind of go diagonally, starting with the last one, then diagonally back to the first one. If we had 4, it would be 1, 2, 3, d4, 1, 2, d3, 4, and so on. Your derivative would be diagonally back from the last one, diagonally back to the first one. All right, so first function, x squared. Second, sine x. Third, derivative of cosine is negative sine. All right. So now first function, x squared. d2, derivative of sine is cosine. And then 3 is cosine. And then derivative of the first one's 2x. And then sine x, cosine x. All right, so our derivative now, we would just combine all this together. I'm going to take this negative and throw it out front. Negative x squared times sine squared x plus x squared times cosine squared x plus 2x sine x cosine x. All right. So our derivative of x squared sine x cosine x is negative x squared sine squared x plus x squared cosine squared x plus 2x sine x cosine x. All right, I know it's a mouthful, but that is our derivative. All right, remember, this has the pattern, it diagonals back. Remember if I said you had 4, it'd be 1, 2, 3, d4, 1, 2, d, whoops, not b, d, 3, 4, 1, d2, 3, 4, d1, 2, 3, 4. And of course you would add all these together when you got done finding all your combinations that you would need. And again, there's that diagonal. All right, they diagonal back, starting with the last one all the way to the derivative of the first one. And you just add them together. Make sure you pay attention to your positives and negatives, and you're good to go. All right, so again, no ticket in the door. I know you're probably getting used to them. I'm kind of getting used to them too. I'm pretty sure y'all aren't upset with me about not having tickets in the door. So just make sure you watch this as many times as you need to fully understand the product rule. All right, see you tomorrow in class.